Okay, today we are going to be graphing the cosine curve. So just like we graph the sine curve from our unit circle, we will do the same thing with our cosine curve. So let me go ahead and show you what we're going to be doing today. So as we move around our unit circle, so here we are at 0, 0, and as we move around, and I'll go to 45 degrees right here, you can see down here, this is the horizontal distance. But when we go to graph it on our unit circle, we're going to flip that so it's vertical. So we are graphing the horizontal distance, but it's going to end up being in the vertical direction on our coordinate plane. But you can see as we work our way around the unit circle, so right there, straight up and down, there would be no horizontal distance. So you can see right here, you'd be at 0. Coming along here, we go all the way around. We get here with the horizontal distance, and we've got -1, because that's where we're at on a unit circle. So this distance right here, -1, but when we come and graph it, it's going to go this way right here as -1. So we're going to do that all the way around our unit circle. Okay, so that's what we're going to do today to create the cosine curve. And that will create our cosine curve. All right, so I guess it's our turn to get started. So here we go. So remember, we're doing cosine curves. So once again, let's make sure we understand what our axes represent. So the horizontal axis, the x, is the angle we rotate. And the y direction is going to represent the horizontal distance this time. Last time it was vertical because it was the sine curve. Today it's the cosine curve, so it's going to be the horizontal distance in our reference triangle. Okay, so first of all, we're going to just start right here at 0, 0. So when we go ahead and draw that, 0, 0, we're talking about this length right here. You can see that's this length right here. But we're going to have to put that in our coordinate plane up here. And because we're graphing a horizontal distance, it's going to end up going, the y value is representing our horizontal distance. It's going to end up going vertical, so it's going to end up going like that. It's kind of weird to think about. That's what we're doing. But remember, the y direction represents the horizontal distance. Okay, then we're going to go ahead and rotate to 30 degrees, and here's our reference triangle. So remember, 30 degrees, that's this length right here. I got too many lengths here. Let's see if we can delete some of those. Just a minute. Okay, so this horizontal distance right here is what we're looking for, and we can tell from our coordinate that it should be the square root of 3 over 2. That's our x value. So that would be this length right here, and that matches. So that's what we're going to put into our coordinate grid up here, square root of 3 over 2 at 30 degrees. So that's going to be about right there. So it's going to be this point right here. Okay. All right, now we're going to move to 45 degrees. So 45 degrees right here. And once again, we're interested in this horizontal distance right here, which we know should be square root of 2 over 2 from our coordinate. We can come over here and measure that, square root of 2 over 2. But when we put it in our coordinate plane, it's going to go vertical. So it's going to end up at about right there. So that's going to be our point. Okay. All right, now we're going to rotate 60 degrees. So 60 degrees is right here. Here's our reference triangle. Once again, we're looking for the horizontal distance, so we can measure that. That's going to turn out to be 1/2. But when we come and put it in our vertical, in our coordinate plane, it's going to go vertical. So it's going to be right there. It's going to be that point. Okay, and now we're going to rotate 90 degrees, which is going to be right here. And you can see there is no horizontal distance, so that's going to be 0. So we're going to be down right here to this point right here. Okay, we're going to rotate around again. So we're going to go to 120 or 2 pi over 3. That's going to be right here. So this is going to be our horizontal distance, and that's going to match up with our 1/2. And we can tell that because that is the x value of our coordinate. But since we're in the second quadrant, it's going to be -1/2. So we're going to go ahead and put that up here. That's going to be a -1/2. So our point's going to be right here. Okay, and we're going to rotate around to 135 or 3 pi over. And so that's going to be right here. Here's our reference triangle. We're looking for that horizontal distance. We know that's going to be a square root of 2 over 2. Let's just check it out. There it is right there. That's the right length. But we want it to be vertical when we come over here to put it in our coordinate plane. So it's going to be right there. So it's going to be this point right here. All right. Okay, now we're going to rotate 150 degrees, which is going to be right here. So once again, here's our reference triangle. We're looking for the horizontal distance, which we know is going to be the square root of 3 over 2. We can match that up. There we go. It does match. But when we put it into our coordinate plane up here, it's going to end up being vertical because the vertical distance is representing the horizontal distance. Kind of weird, huh? All right, and now we're going to rotate 180 degrees. And 180 degrees, that distance is going to be 1. So here we are, we can check it out. 1, so we're going to go ahead and put that vertical right here. So that's going to be right there. Okay, and I think now we're going to start to see some symmetry happening. So I'm going to kind of move this a little bit faster now as we rotate along. We're going to have our square root of 3 over 2 right here. So that's going to go to this point right here. Then we're going to have square root of 2 over 2. Whoops. It'll be right here. And then we're going to have a 1/2. And then we're going to be at 0. And then we're going to be at a 1/2 again. Oops, right here. A 1/2. Square root of 2 over 2. And square root of 3 over 2. And then back to 1. Okay. So there's our cosine curve. So if we go ahead and connect those, we can see that cosine curve right there. So that's one cycle of the cosine curve. So cosine curve, when we start to graph the cosine curve, it's going to start at a max or a min, depending upon if it's positive or negative. Typically, all the positive ones start at the max, and the negative ones start at a min. So that's our cosine curve. And it also has a 5-point pattern. So it started at a max, and then it went to an intercept, and then it went to a min, back up to an intercept, and then back up to a max. And just like the sine curve, these 5 key points divide our graph into 4 regions. You got 1, 2, 3, 4. Whoops, that's kind of, let's see if I can draw that a little bit better. There we go. So we got 4 regions right there. So, and same thing, it's because we're doing the intercepts on the unit circle. There's 4 quadrants in our unit circle. So there's 1, 2, 3, and 4. So it's going to always divide our cosine curve into 4 equal parts. You can follow that pattern in the other direction if you want. So if it's at a max, we're going to go to an intercept, down to a min, then to an intercept, and then to a max. So keeping in mind, they always alternate. Max, intercept, min, intercept, max, intercept. They should always alternate. Midline, we can see that our midline right here, this is our midline. We can see the midline goes through the middle of the graph, and that's what should happen. Our midline is going through the middle of the graph. Okay? All right, let's go ahead and practice a few. So we're going to have, oh, sorry, before we do that, this is going to show you how the sine and the cosine curve are related. They're just a shift of each other. So you can do a phase shift of pi over 2, and you will have either the sine or the cosine curve, depending upon which way you're shifting and which curve you're shifting. You can see right here, here's the max of the cosine curve, and here's the max of the sine curve, and they are pi over 2 apart. So if you just shift them pi over 2, you'll end up with, you know, a sine curve could be a cosine curve or vice versa. Okay, so once again, for the cosine curve, we have A, B, H, and K. We're not doing B today. We're doing A, H, and K, just like we did last time with the sine curve. So A is our amplitude, H is our phase shift, and K is our midline. So all of those are things that we did last time with our sine curve. So we're going to go ahead and do our cosine curve. So first of all, I'm going to just kind of analyze each equation before I start to graph. So right here I see I have an amplitude of 2, so I have an amplitude of 2. We're not doing any period changes today, so that just means it's going to be 2 pi, one time around the unit circle. I'll figure out what the domain is here in a minute. If plus k, that there's nothing added here, so that means my midline is right here at 0. And I know that the cosine curve always starts at a max. Well, if my amplitude is 2, then that must mean it's going to start at 2. And then where's it going to end? Well, my period is 2 pi. It's going to end at a max again. All right, so what we need to do is we need to go ahead and divide that into 4 equal parts. So here's a division, and here's a division. So we've got our 4 equal parts. We just got to get our points in the right spot. So let's go back to our starting point. We started at a 2 at a max, so remember we have to alternate max, intercept, min, intercept, max. So that must mean I must be at an intercept right here at this division. Now remember, max, intercept, min. So you're going to have to go down to a min, back to an intercept, and then back to a max. Kind of makes this valley shape. So there's one cosine curve. You can keep following that pattern, and you can draw more cycles of the cosine curve if you want. So I went backwards. There we go. You could go forward more if you wanted. And there we go. Used all of our graph paper. Okay, domain is all reals. And the range on this one is going to go from -2 to +2. Okay, over here, when I look at this one, I notice it's a cosine curve. I see that I have a k, so this is my midline. So my midline is at y equals 3, so I'm going to come up here to 3. I'm going to draw my dotted line. My amplitude is 1. Remember, your amplitude's right here, so amplitude is 1. We aren't doing any period changes, so one time around the unit circle, so it's 2 pi. And we'll go ahead and start that. So cosine curve always starts at a max or a min. Since the amplitude's positive, it's going to start at a max. So it's going to start up here, 1 from my midline, so it's going to start at 4. And the period's 2 pi, so it's going to end at a max. It's going to start at a max, and it's going to end at a max. And now we just got to cut this into 4 equal pieces. So there's 1. There's my 4 equal pieces. Okay, so here we go. We're going to go ahead and graph that. We're going to start at a max. So remember, we alternate max, intercept, min, intercept, and max. And that should make one cosine curve. And notice the midline goes through the middle of the cosine curve. That's what should happen. And you can keep following that cosine curve if you want. And there we go. There's another cycle. So there's our cosine curve. So domain is all reals. And the range is from 2 to 4. Okay, I'm looking at this one. I notice it's a cosine curve. So I also notice a negative, so that means it's going to reflect. And there's a 1 there, so my amplitude is 1. I've got a phase shift, so this is going left pi over 2. And the plus k, not there, so my midline is going to be at y equals 0. So that's our x-axis. Y equals 0 is your midline. All right, and I'm going left pi over 2, so here's left pi over 2. Now remember, cosine curve always starts at a max or a min. Normally it starts at a max, but because I see a negative sign there, this time it's going to start at a min. So my first point is going to be right here. My period is 2 pi, so I'm going to shift to the left 2 spaces from my 2 pi, so it's going to end right there at that min. Okay, we need to divide into 4 equal pieces. So here's the middle of that, and the middle of that. So cut it into fourths. 4 equal pieces. All right, so cosine curve starts at a min. It's got to go to an intercept. Then it's got to go to a max. And then to an intercept and back down to a min. So this time it kind of made a hill shape instead of a valley because it's reflected. And you could keep following that pattern. Double check. Is your midline in the middle of your cosine curve? And it is, so I know I've done that right. Sometimes students tend to switch to a sine curve when they're graphing a cosine curve. So make sure your midline always goes through the middle of your graph. Period here was 2 pi. We already said the amplitude was 1. Domain is all reals. Range is going from -1 to +1. Okay, over here, I notice that I have an amplitude of 3. There's my amplitude. This is my midline. So midline of -1. So midline is y equals -1. Amplitude of 3. Then we're not doing any period changes today, so that's just going to be 2 pi. And cosine curve always starts at a max or a min, and since 3 is positive, we're going to start at a max. So let's go ahead and draw in our midline. So we're going to go 3 up from the midline. Okay, and we're going to end 2 pi away. So 2 pi away is right here. So I'm going to start on the left here, and I'm going to end on the right. We got to cut that into 4 equal parts so we can get our key points in. There's 1, cut that in half, and then cut that in half. Okay, we've got our divisions. So now let's remember, we start at a max, then we go to an intercept, and then we have to go down to a min. So 1, 2, 3 from our midline, because remember our amplitude is 3. Back to an intercept, and then back up to a max. So before you sketch it in, does it look like your curve, the midline goes through the middle of your curve? It does for mine, so I'm going to go ahead and sketch that in. Remember that midline should always go through the middle. And then you can keep following that pattern and graph more cycles if you want. And there's one more cycle. And notice that they're curved. The cosine curves tend to look more V-shaped, like absolute values, and that's not what we want to have happen. We want them to be curved, so do your best to make them have a curve. All right, so there's our cosine curve, and the domain is all reals, and the range on this one goes from -4 to +2. Okay, so this one's got more information. So we've got a lot of things happening. So once again, our amplitude is 1. So amplitude is 1, because remember, amplitude's always positive. The negative sign is going to reflect, so that means we're going to start at a min. And I'm just going to write that so I don't forget. Okay, we're going to start at a min. Here's my midline. And this one's my phase shift. So our midline is going up 1, so it's going to be y equals 1. Our phase shift is going left 3 pi over 2. So we don't have a spot for that, but we are going to go left 3 pi over 2. And the period is 2 pi. We're not doing any period changes today. Okay, so let's go ahead and put in our midline. So up 1, I'm going to draw that in. I'm going to go left 3 pi over 2. So 3 pi over 2 is going to be right here. Okay, so my cosine curve normally starts at a max or a min, but because it's negative, we'd already said it's going to start at a min, and my amplitude is 1, so I'm going to start 1 away from my midline, so that's where it's going to start. Now, we just need to figure out where it's going to end. So right here, we're going to be, we don't go clear over here to 2 pi. That's way too far. We're going to end up being right here is where we're going to end up. See how on this end right here, on this side, let me look. Let me show you. On this side, we are just 2 spaces away to being 2 pi. So we've already got from here to here would have been 2 pi, and we're just 2 spaces, so I'm just going to shift it to this way. So that's how I knew it was going to end up at pi over 2. Okay, so once again, we got to divide that into 4 equal parts. And if you can't get your graph to divide into 4 equal parts, then maybe that might tell you that you've got your ending in the wrong spot. So there's the middle, there's the middle of that, and there's the middle of that. Okay, so my cosine curve starts at a min. Remember, we alternate min, intercept, max, intercept, min. Does my curve go through the midline? Yeah, the midline's in the middle of my curve. So our curve should never sit on the top or below the midline. The midline should always go through the middle of your curve. Okay, so I'm just going to keep drawing a couple more. Follow that. There we go. So domain is all reals. Range on this one is from 0 to 2. Okay, over here,